Hey everybody, this is Mr. Schaefer, and I have for you another video podcast lesson here on quadratic functions. We've looked at parabolas, we've graphed parabolas, and we've kind of studied the various patterns of quadratics. They all have x squared in them. And this lesson is going to take us through a few examples that involve some applications of these quadratic functions. And to begin, I want to remind you that this idea of minimum and maximum will be a really important one. In a parabola, there's going to be a minimum value and a maximum value. So anytime we're looking for some kind of maximum or minimum in a situational contextual example, think about using the vertex and finding what that y-coordinate is. So first blank right here says the max and min values may be found from the, fill this in, the y-coordinate of the vertex. And that keyword is going to be the word value. That word value represents the y-coordinate. Now with a calculator, we looked at this a little bit earlier, we can find that x-coordinate. Algebraically, the formula would be the opposite of b divided by 2 times a. And then whatever y value goes right here, that's going to be my min or max. Remember that parabolas open up or down, creating either a minimum or a maximum. Remember also that in the calculator, in the TI-84s, we can hit second trace, and we'll look for option 3, which is a minimum calculation, or option 4, which is a maximum calculation. And so we'll look at those maybe later on with the calculator moving forward. So with this video podcast today, I'd like to actually share with you how to do 2 examples. Example 1, the daily revenue R is achieved by selling X pairs of shoes and is modeled by the equation R of X equals 50X minus 0.01X squared. So this is a quadratic function. I know it's a quadratic because there is an x squared. Be careful though, it's not written in standard form. If I were to write that in standard form, I would want that x squared term to be listed first. And maybe we want to write it that way just to avoid any confusion. The a value is negative. If that's the case, I'm going to have a parabola that opens down. So my vertex point right there is going to be a maximum. And look at the very first question. It says, what is the maximum revenue? The maximum revenue, which is R in this function. Well, again, that's simply just asking me for the y-coordinate of the vertex. So let's find the vertex. Opposite of b divided by 2 times a is going to be the x-coordinate of the vertex. Opposite of b would be negative 50 divided by 2 times negative 0.01. So negative 50 divided by negative 0.02 would give me a value of positive 2,500. 2,500. Now what I found is the x value. Remember back here, the x value is the pairs of shoes. But the output, the y value, would be the revenue. So that's what we're searching for here. Simply plug in 2,500 into the r function. What's r of 2,500? So 50 times x, but my vertex x is 2,500, and then minus 0.01x squared. So we're plugging in x into the function to find the output, that matching corresponding y value to the vertex x. Here it's going to be 625,000. And that would be the maximum revenue. So I can write that down. Units here are dollars. Question part B says, how many pairs of shoes must the firm sell to hit that maximum revenue? Well, we already found that out. That's the 2,500 number. So 2,500 pairs of shoes. The vertex tells us a lot about a quadratic function. X was 2,500. Y was 625,000. That vertex XY gave me the maximum revenue along with the number of shoes needed to attain that maximum revenue. So one more example. Here's a quadratic function involving marginal cost of manufacturing cell phones. Notice this, it's in thousands. We'll come back to that later on. And the function there is c of x equals 5x squared minus 200x plus 4,000. The a value is a 5. This parabola is going to open up because a is positive, meaning we have a minimum. The vertex will be a minimum in this quadratic function. How many cell phones should be manufactured to minimize the cost? That's asking you to find the vertex x. What is that minimum marginal cost? That's the vertex y coordinate. If we find the vertex, we've basically answered both of those questions. Let's use the formula. Opposite of b divided by 2 times a would be positive 200 divided by 2 times 5. 200 divided by 10 is 20. How many cell phones? 20 cell phones? Not exactly, because x is given in thousands. So that little number 20 really means 20,000 cell phones. Be careful with our value and the units right there. So finally, what is the marginal cost? The minimum marginal cost. Well, to compute that, we need to find the y. I'm going to plug in 20 into the function for cost. So 5x squared, but x is 20 at the vertex, minus 200 times x, but again, x is 20, and then plus 4,000. Check with your calculator, that output should be 2,000. So my vertex for this quadratic function is the ordered pair 20, 2,000, where 20 represents the cell phones. Remember, that's in thousands. And the 2,000 represents my marginal cost in dollars. So the minimum marginal cost would be that cost at the vertex of, in this case, $2,000. There are 2 examples of applications of quadratic functions and how we can use the vertex to find the minimum or maximum values in each of these contextual situations. Hope that was helpful to you. Thanks again, as always, for watching.